NENOMATICA, where mathematics meets YouTube excellence. In this example, we study how the roots of a quadratic behave when the coefficients of x squared and x go to 0. Let us write the theorem clearly. The statement says, if both the coefficient of x squared and the coefficient of x approach 0, then the magnitudes of both roots blow up to infinity. We will prove this in 2 stages. First, let A approach 0 while b is non-zero. One root tends to negative c over b, and the other root must grow without bound. Second, let b approach 0. That forces the previously finite root to diverge as well. We use 2 standard tools. Vieta's formulas. The sum of roots equals negative b over a, and the product equals c over a. And, of course, the quadratic formula for the exact roots. Stage 1. Let A approach 0 while b is not 0. The quadratic is close to the linear equation bx plus c equals 0. So one root approaches negative c over b. Then, by the product formula, the other root must satisfy x1 equals c over a divided by x2, which diverges in magnitude. Stage 2. Now, let b approach 0. The finite root from stage 1 was negative c over b, so its magnitude also diverges. Thus, both roots have magnitudes that go to infinity. Conclusion. As A goes to 0, and b goes to 0 in the quadratic ax squared plus bx plus c equals 0, the absolute values of both roots tend to infinity. One quick intuition: the product of the roots equals c over a. As A approaches 0, the product blows up. So once one root stays finite, the other must grow without bound. In this lesson, we will use a helpful theorem about quadratics to decide when both roots blow up to infinity. Here is our example. We are given left parenthesis m squared minus 1 right parenthesis x squared plus left parenthesis m squared minus 5m plus 4 right parenthesis x plus m plus 10 equals 0. Our goal is to find all m for which both roots tend to infinity. First, the theorem. If the coefficients a and b of the quadratic ax squared plus bx plus c equal 0 both go to 0, then the magnitudes of both roots go to infinity. Intuitively, when m is tiny, the parabola flattens and one root runs away. When b is also tiny, the second root cannot stay finite either, so its magnitude runs away as well. A quick proof sketch. If A goes to 0 while b stays non-zero, the quadratic behaves like a very small curvature plus a linear term bx plus c. One root escapes to infinity, and the other tends to minus c over b. If b also goes to 0, that remaining root becomes minus c over 0, which diverges, so its magnitude goes to infinity too. Now, we apply the theorem to our equation. The coefficient of x squared is m squared minus 1, and the coefficient of x is m squared minus 5m plus 4. For both roots to blow up, we need both coefficients to go to 0 at the same m. So we solve the system at equals 0 and b equals 0. Solve them. From m squared minus 1 equals 0, we get m equals plus or minus 1. From m squared minus 5m plus 4 equals 0, we factor to m minus 4 times m minus 1 equals 0, giving m equals 1 or m equals 4. The common value is m equals 1. A quick check. If m equals 1, then A equals 0, and b equals 0 exactly, matching the theorem's limiting situation where the roots cannot stay finite. Therefore, the only value producing both roots blowing up is m equals 1. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.